Our next speaker in the first part of the keynote, Jan, it's all yours.
Thank you. So contrary to the other speakers, I do have slides. Just have to set them up. All right. First of all, welcome here. It's a great honor to be here as well, although I'd rather be in Paris right now. My name is Jongboom. I'm a software developer. I work for Cloud9. So contrary to like everyone in the room, I'm not doing Plone full-time or even part-time. If you have questions for me, you can ask them after the session or ask them on Twitter. I'm act.bernard, or you can tweet him to our channel, Cloud9 ID. So that's all fine. So this is the program that we have today. First, we'll do a little history lesson. We're going to check out the state of JavaScript, where it came from, where it is now. That's interesting stuff for you Python guys. After that, I'll discuss how we built Cloud9, why we built Cloud9, the vision behind it, and I will combine that, the JavaScript, the Cloud9, and Plone, into some full action cloud super demo thing that you can tell your wife about. So here's the very first thing that we actually do. We go back to 1995. 1995 was the year that Alta Vista was still a major search engine. The year that Ajax won the Champions League. Yeah, that's really, really long time ago. And that Montel Jordan had a #1 hit with "This Is How We Do It." If you want to see me dance on that, you have to check on the after party. But 1995 was also the year that a new language appeared called LiveScript. And this was shipped with Netscape 2.0, one of the very first versions of Netscape. And this was developed by a guy named Brendan Eich, currently CTO of Mozilla. And they decided they wanted a simple scripting language that you can use to transform the page that you're looking at that moment. Well, contrary to the name, JavaScript, it's not really like Java. JavaScript is more like scheme in the browser, but with like a C syntax. And the reason they chose for the name JavaScript was like, well, basically all political. Because at the very same moment, more or less, Netscape also announced Java support in their browser. And I thought, hey, this would be a very good idea to just ride the wave and just call our new language JavaScript. It was a pretty bad mistake, if you ask me. And this is what Brendan had to say about it, actually. JavaScript had to look like Java, only less so. It had to be Java's dumb kid brother or boy hostage sidekick. And he added to it, it had to be done in 10 days. 10 days, because otherwise something even worse would have happened. So, can I see some hands who used JavaScript in the early days to change the status bar of your web page? And yes, indeed. That was basically all you can do back then. It had no cool features whatsoever. But in 1999, a company decided they wanted to change something. They, in this case they is Microsoft, wanted to build a web version of Microsoft Outlook 2000. And it was called Outlook Web Access. But up until then, it was not possible to send data from the client to the server or the other way around without having to refresh your whole page. So they decided they wanted to build an ActiveX component, a plugin for Internet Explorer 5 that allowed you to do HTTP requests either from JavaScript or from VBScript to a server. And that was the birth of the XML HTTP request. And the name was given by Mozilla that took over the Netscape project. So here we are back again in 2000, and they gave it the actual name. And XML HTTP request is the basis of all that we call now Ajax. And they won a title last year, so I'm very proud. And now that you can finally have asynchronous communication. You don't have to refresh the page every time that you want to update something. Oh, sorry. Every time that you want to update something, you can actually build useful applications. So Google decided they wanted to build something cool as well, and what did they come up with? An email service, yes. So in 2004, Gmail launched, and it was like, oh my god, it's the first web application, it's so cool. Oh yeah, you can like click on an email and then it will refresh in place. So a technology that Microsoft originally created to server Outlook web access was now used by Gmail, and that's now the largest free email provider. A shot in the foot. Still not very beloved JavaScript after that. So this is actually some code that I wrote. I'm not very proud of it. I wrote this in 2005, and this is in a school website. I can give you the URL if you like. I hate JavaScript. That's pretty strong. I hate JavaScript, but for this I'm forced to. And this is just to show a simple pop-up window. JavaScript was not very beloved back then. And I know from a couple of the Plone developers that JavaScript didn't gain a lot of love in the beginning days of Plone. And maybe still not even. And there are actually reasons for that. Because the implementation between different vendors really differed. If you wanted to do the Ajax, the thing that Microsoft even invented in IE6, IE7, or IE8, the implementation differed. You couldn't write a simple 5-line script that did an HTTP request and have it work in all those different versions of a browser of the same vendor. And other than that, there's also a lot of crap in the language. If you want a good laugh, check out the with statement in JavaScript. It's really, really bad, seriously. So it's not really surprised that the best sold book about JavaScript is called JavaScript: The Good Parts. And it's 8 times smaller than the definitive guide. So but the reason people actually really hated JavaScript was not the language itself. It's a DOM, it's a document object model. And the document object model is a direct mapping of a C tree structure that was like opened up to JavaScript because, well, it had to be done in 10 days. Come on, I'm not going to think of a cool API to use. This thing was never meant to be scripted. If you're doing JavaScript, then you know the following code sample. This is a little sample to get all the diffs on a page with class Plone. 7 lines of code just to get some stupid elements. And it probably wouldn't work cross-browser anyway. This is the reason why I actually hated JavaScript. It was not like open a pop-up, that's hard or something. No, it's stuff like this, dealing with a DOM, that make me hate JavaScript. So in 2006, things started to change, or actually the years after that. Because jQuery got launched. And jQuery is now used by 52% of the top 1,000 most visited websites. It's by far the largest JavaScript library used ever. Maybe the largest library used in any case. But the actual power that's there, you saw the effect? The actual power there comes from Sizzle. Sizzle is an open source selector, CSS selector engine that runs in JavaScript. And Sizzle powers the code that lets you say, hey, give me all the divs give me all the elements that have a class named Plone. And after that, things really started to change. If you check the Google Trends volume, we have Java in red and JavaScript in blue. And after 2007, you finally see a rise in JavaScript. After 2007 or 2008, JavaScript was beating Java in terms of news volume, in terms of searches on Google. It's like the dumb kid's brother actually has grown up or something. That's really cool. And now we got the DOM out of the way. people actually started to care. People started to appreciate JavaScript. So companies like Google and Mozilla jumped into that hole and thought, hey, if people actually are caring about JavaScript, then we need to care there as well. So they started to build faster VMs, better VMs. Google did it with V8. V8 is basically a library and executable that you can just grab, and then you have like this cool JavaScript engine in your own project if you want to reuse it. Mozilla followed with SpiderMonkey. Fast, embeddable, cool. And even Microsoft is now trying to get up to speed as well with their new IE10. And even the ECMAScript committee, and this is the committee that controls basically everything about JavaScript, they were fighting their asses off in the 2000s. And it was all over ECMAScript 4. And they got back together, and now they're happy, happy fellows again. And they launched a new standard, ECMAScript 5. Everyone was happy. And in 2009 even, a conference fully about JavaScript. Who could have thought of that in 2005? A conference fully about JavaScript was even launched. JSConf, first time in the EU. And at that very first JSConf, a new technology was launched called Node.js. And the idea in Node.js allows you to run JavaScript on a server. We're going back to the real definition later on. And it's not very new. You know, even in 1995, the year that LiveScript got introduced, Netscape had LiveWire server. And this was a server component that allows you to write JavaScript on the server as well. So you have one language to write client and server. And for a very long time, I thought that was the unique selling point of Node.js. I thought just Google's V8 engine as an executable. That was I would have said that 1.5 years ago. Trust you, this wasn't 1.5 years ago. It's more like 15 years ago. Well, you get the point. So the actual power doesn't come from the idea that, hey, I can run JavaScript on a server. Oh yeah, that's awesome. No. The actual power comes from the underlying platform. And this is called libuv. And libuv is a cross-platform library. It has the fastest I/O and networking library on this freaking planet. And you can run it on Linux, you can run it on Windows, OS X, Solaris, you name it. It has nothing to do with JavaScript. It's just C. And how libuv works is by abstracting, blocking platform API calls away. What? Yes, indeed. So let's say if you've ever touched like the real file system on a very low level, if you ask for a file on hard disk, it doesn't say, all right, now I'm going to block the hard disk for all other users. I'm going to find this file, then I get back to you. No, that doesn't work. The hardware, when you actually read a file, works like this. It says, hey, give me that file. And another program also says, give me that file. Then the hard disk says, all right, so part of this file is here, and the other part is there, so we'll just make one spin and get all the data, and then notify you when you're done. That's just how it works on a basic hardware level. The operating system vendors, they don't really like that approach. They try to abstract that away. And that's still some legacy that we have from the 70s or the 80s, where writing synchronous code is really easy. Like, this is a simple C example. I'm going to create a stream to a file, then keep reading this file until I hit end of file, and then, in this case, pipe it to standard out. This is a pretty good sample. It's nice, it's streaming, it has low memory usage, but it's synchronous, even though the underlying hardware is asynchronous. And it's synchronous because it blocks your current thread. You can't do other things in this program while you're waiting for the next data to arrive. Is that bad? Well, we'll find out in a sec. So this is how libuv organizes it. We still say, hey, we have a stream. We're closer to the hardware. We say react on events. If the hard disk says, hey, I have some data for you, then we react on that. In this case, we have a function that's on data. And that will fire only at the moment that there is data. And there's a close event and we can kill the program. So libuv gives you all these APIs and gives them an async flow. And it does this for file system, for networking, for DNS, all that stuff. But why would you care? I think we're all doing web development here. Pretty much, yes. And in web development, threads are not free. If you're doing a little C program and you read a file or you download a web page, who cares that your thread blocks? But a simple thread on a Linux system takes 2 megabytes. It doesn't do anything. So if you need a lot of threads because you need to have a lot of connections, because every time someone visits a page on your website, every time someone visits the Cloud9 homepage, a new thread is spawned up or gathered from the thread pool. And in this time, this whole thread is blocked. Okay, still, why would I care? So let's say that you have a chat application, a long polling application. You open a connection to the server from the client, and the server keeps that open until you have some data to send back, until you have a chat message. So that might take 30 seconds. On a simple 32-bit machine that has 3 gigabytes free for Apache, this will limit you to 300 concurrent connections, because your thread will take up like 10 MBs. So you have this powerful server, it's not doing anything except for keeping connections open, and you're limited to only 300 concurrent connections. It also means if you do a database call in there and it takes a second, you can only have 300 people per second on your system, even when the server is not doing anything. So with the asynchronous model in libuv, it's all evented. It works via an event bus. The event bus is one single thread. That means you only have to allocate that 10 MB of RAM one time. That means that with your simple server, instead of 300 concurrent connections, you can now do tens of thousands. And that's really powerful if you're doing web, because then you really care about the number of connections that you have, that you can have. If you, for example, this is a weird idea, if you're going to build an IDE online, it really matters how many people you can have on a server, because servers are actually expensive. So it's a great solution if you do something that requires a lot of concurrent connections. If you have a fast-paced website, if you do a lot of database calls that take a long time, if you do chat messages, something like that, this idea is really cool. So that's basically what Node.js is all about. Node.js are simple JavaScript bindings to libuv. So it's actually a pretty small shim, the server-side part there. So Node.js is JavaScript bindings to libuv. And it's basically the same as we saw in the DOM before. The DOM, you know, the API to access the internal tree structure of a web page that's written in C. You do it with a little bit of JavaScript magic. So Node.js is basically that. It's just JavaScript bindings to asynchronous C code that allow you to write non-blocking code that handles a lot of concurrent connections. So if you want a good definition of Node.js, you can brag about this in the pub later. I know what Node.js is all about. It's JavaScript bindings to libuv with standard libraries in JavaScript. And then this JavaScript is executed in V8. That doesn't mean it's like exclusive to JavaScript. There are also bindings for Lua with Loveit, or C++, SpiderMonkey, probably one or two Python implementations as well. But the JavaScript part is the most mature. Has the largest set of third-party modules. So probably a couple of people are thinking, hey, why would I choose Node.js over Twisted, Python asynchronous event bus based thingy? Well, Ryan Dahl, this is the guy, when he was developing Node.js, he thought, hey, which language would I want to use to build this stuff? Why would I choose JavaScript over Lua or C++ or over Python? He didn't really care about JavaScript either. No one seemed to care back then. But he thought, hey, the same thing that happens with Twisted on Python is you guys all have an ecosystem of Python modules of stuff, for example, Clone, that you want to run on a thing. So when someone gets there with like, hey, I got this cool event bus model thingy that will not block your server and your performance will increase by 1,000 times. You're like, but hey, I want to run Clone on it. And then suddenly it all blocks because the code is not written asynchronously. Didn't really happen with JavaScript, so that's all fine. So that's one of the reasons, probably a major reason. There's no ecosystem, so the complete asynchronous ecosystem can just be written. There were no modules that people wanted to use. But maybe the most important one, and now we get back to Ajax again, is that everyone who's doing JavaScript is already familiar with the concept of evented I/O, of doing a call and then like not knowing when you get back, but just notify me when you're done. Can you imagine what a mess it would be if like every time you do a call via Ajax, your complete browser would lock? That would be ridiculous. No, you say, hey, give me that page and then I will react on it at the moment that we're done. That's like the concept that you use in a browser as well. So with the fast VM from Google, with V8, we now got a cool JavaScript server-side thingy as well. And then we figured, hey, so we got one of the fastest server-side libraries available with Node.js. And we got a client-side language that is actually loved by people. And people build on it. People build on it a lot. It's probably the most used language in the world. They're like, hey, we're doing everything online, from online banking to editing documents. And JavaScript is the language of the web. Then why do normal developers, like the Java and .NET guys, have all the great perks? Like, hey, they have IDEs, testing tools, continuous integration suites, deployments, I don't care. JavaScript developers, not so much. You guys probably know this from Python as well. You're like, yes, I have syntax highlighting. I'm like on top of the world. So we decided we wanted to change that. We wanted to build an IDE especially for the JavaScript people in this world, or actually anyone who does dynamic languages. We wanted to bring like the cool stuff that normal developers have to the dynamic language as well. And what better way to embrace the web than actually build on the web? So this is Cloud9. Cloud9 is an IDE. It runs online. It's open source. You just download it, edit stuff, play with it, run it on your own server. And it's completely built in HTML, CSS, JavaScript with Node.js on the server side. But it's still like a fully functional IDE. So we got debugging, variable inspection, hovering over, editing stuff. We use smart code completion with like inline documentation and stuff. At the moment, this is only available for Node.js. Too bad. But in a couple of months, we'll support Python as well, so you can do like your clone development and stuff all within the cloud. Yay. Or within your own browser. Ooh. So that's all cool, but the actual power that we have is that we give you a free Linux VM at the moment that you create a project with us. Free Linux VM? Yeah. So you can run all the stuff that you want. If you want to run Java, install Java. Want to do some weird custom-built version of Python, feel free. Want to play with memSQL, the stuff that Facebook launched a couple of months ago, just do it. And to control it, we got a real terminal within your browser as well. And this is like a real Vim, it is Telnet, you can watch Star Wars, the ASCII movie or something. But maybe the coolest feature is collaboration. And you guys know this from Google Docs. Collaborative editing means that when I have a bug, I can say to my colleague or to someone in San Francisco or I don't know where, help me with this. And he can come into my document, I can see my cursor, he can see me type, but we can also debug together. It means like super increased productivity plus. If you don't believe me, I'm going to show you it in a demo in a couple of minutes. So we're doing this full life cycle thing here. You can create your stuff, you can pull it in from GitHub, you can pull it in for FTP. Then you can run it, you can debug it. The running is available for Python as well. Debugging, not yet, but will come shortly. You can test the stuff, share it, collaborate with it, and then deploy it. You never have to leave your browser here. So it's one of the talks that I do is actually doing PhoneGap development. You know, PhoneGap is a library that allows you to write HTML, CSS, JavaScript applications, and it compiled them to native applications for your mobile phone. And you can do that without leaving your browser. Just create a new project, test it in the browser as well, and then deploy it and install it on your mobile phone. That's pretty cool. So this is how our architecture looks like, because people tend to ask a lot of questions about this. In our data center, we just have Cloud9 code. It's all the stuff. And then in a different part of our data center, we got all the VMs that we use for our clients. At the moment that you don't use it, we'll put it in hibernation. So this means that your VM will never be used by someone else. So you saw the cute kid I was like 15 years ago. Back then, my greatest hobby was to crash my computer, actually. And like playing illegal games, which worked nicely together. So after I crashed my father's computer for the 6th time in a month and got a blue screen because I installed some weird key generator on that machine. Still not very proud of it. They actually told me, hey, it's like way smarter if you just do it in a virtual machine. So he installed some virtual machine thingy where I could just run my key generator and then clean it up when it gave blue screens, which was pretty fast most of the times. And it's cool if you can do that to your development environment as well. So let's say, hey, I'm installing Python 2.7.3 with like cool additions and shit. And oh, my project broke. Reformatting your laptop takes a little while. In Cloud9, you just say, hey, all right, kill this freaking project. I'll just create a new VM and try it again. Like, cool. You can't run keygens on it, though. Or we'll kill you. So that means you can install everything. So we ship it with Python 2.6.6, which is basically an ancient version, as I understood. But you can just compile Python 2.7.3 on it. So if you need a project that has that, say clone, just grab the sources and build it. Will just work fine. And you can run MongoDB on it, Postgres, and pretty much you can do clone as well. So I didn't got clone to work on one of the free VMs. So I need some wizard to help me with that, because the libxml dependencies thingy. Yeah, that's the pain. So let's say you have trouble installing something or you need more power, then we have a second solution here. And that's called bring your own VM. So let's say that a new hire comes in at the Cloud9 office. Like, hey, bright, new, super kid. So we hand him out a laptop. Then we go to EC2. We create a new server for him. We spawn it up with like Ubuntu and our source code. And just give him the IP address. Like, hey, all right, have fun, this is your machine. Within 10 minutes, this machine is ready. And he's ready to work from wherever the hell he wants, because you can bind this machine into Cloud9 the same way you would do with your free virtual machine. So that means you can work on a quadruple high super instance thing that costs $5 a minute on your company's credit card, if you like to. If you need like the super ultimate power. Sorry, need some water. So because I couldn't get Plone to run on my own, on like a free virtual machine, I took this approach and I installed Plone via the unified installer that didn't complain about libxml and installed it on my own virtual dev machine. And it's basically installed in 5 minutes. And now I got a Plone installation, or actual Plone source code running in the cloud, accessible from anywhere. I'm going to demonstrate it to you now. Right, so starting to edit this project is basically as simple as going to a URL on a web page. In this case, C9AO Jongboom Plone SSH. That's it. So this is Cloud9, and it has a freshly installed Plone installation via the unified installer. You can see the Z instance folder here with your build outs and your develop CFG and all this stuff. That probably says more to you than to me. And as I said before, this is just a Linux server. So that means that I have terminal access to it. So I can spawn a new terminal by just saying, hey, few terminals, new terminal. And I would be very grateful if this would connect. Very grateful. Oh gods of the Wi-Fi. So it will not. So let's refresh this thing. Maybe it will now connect. All right, I see a blinking cursor. That's most of the times a good thing. The good thing is I have a video of the demo as well. Oh, shit. I don't have to open like the source file. Right, so we're here in my demo project. I still have the freshly installed Plone installation on the same URL as just seen before. And when I want to open a new terminal, I just say, hey, fuse terminals, new terminal. I'm just on a Linux server, so I can execute basically everything that you would do normally on a Linux server. And to prove that, I'm going to show you how you can edit the build-out config file with like super real Vim. Yes, there are probably a couple of Vim lovers who will now go completely mad. So this is like, yes, thank you. So now I can search on this like normal, just /8081. So I'm setting my HTTP address to that. And this is the thing I like most. It's subtraction-free mode. Just like go into Zen mode and just have your editor, and that works for the terminal as well. So if you don't want to get bothered by Cloud9, just use like real Vim and don't complain to us. So it's pretty cool. So that's also Cloud9. So now let's quit Vim and then, I don't know, start Plone. So as I learned yesterday, you can start Plone in debug mode via bin instance fg or something. So I'm not going to do that in a terminal. I'm going to do it in a console, which is basically the same functions as the terminal. But the cool thing is that it shows you the status of your running application from every tab. So you don't have to switch back to the terminal when you're editing files if you do it there. So when I now spawn it, it will get started. That's the cool thing about video, can't break. So now we got a debug instance of Zope and Plone running here. Here's like the cool question, is this going to work? This is running on port 8081. I configured my machine to listen on C9.dev. I want to go to C9.dev 8081. I got Plone running in the cloud. So that's pretty cool. So let's assume, just assume that I'm a novice Plone developer. It's completely not true, of course. And I want to edit the logo that I have here. Alright, so I figured out that this logo is in a little file called logo.pt. That's probably not the way to do it, but I figured out it worked this way. So I can bring up the go to anything dialog and I just start typing here logo.pt. And I have this file open in seconds. So because they have like this weird extension called pt, I have to set the syntax of my editor to XML first, and then I have some basic stuff so I can do like, I don't know, code folding and other cool stuff. So if someone wants to improve this in a sprint and do like cool code completion or something, be my guest. So I can do like code folding and just like basic stuff here. And here's the thing I like actually most about Cloud9. It's called multiple cursors. So you can like make multiple insertion points in different places, and you have like cursors that you can use to type. And now I do it with the mouse, but you can also do it with a keyboard and say, hey, get me the next instance of view in this document. And then you can also type in two places at the same time. So you're like collaborating with yourself. And if you do like Ctrl-Z, it also does the same thing. There's a lot more I'll show you later in the demo. So what we're now going to do is ask for some help from one of the smarter Plone developers in this room, which is me again. So we'll first quit our process because we don't need it at the moment. And sharing a project for a collab session in Cloud9 is basically the same as sending a URL over to someone else. So I have the URL copied. I'll now spawn like this super cool Google Chrome incognito window, porn mode, as you might call it. And I navigate to that page. So this is the very first moment that my coworker is accessing my project. So he has to log in first. He's also named Jan. It's really strange. And now he's here. Because it's a private project, we got public and private projects in Cloud9, he has to first ask for access. In this case, you just say, hey, do you want to request access? Yes, I want to. Please. Now the main user gets an invitation from this user and say, hey, do you want to give him read-write or read-only or no access at all? In this case, I want him to actually do some stuff for me. I just say, hey, write this code for me. Just don't tell me how to do it, just do it. I don't care. So I give him read-write access. So now he has his editor open and he sees exactly the same file as me. So that's synced. You know? I have a file open, I will open it in your IDE as well. So when I close it, it will close in the other window as well. Wow, cool. And I can reopen it again via Command E. And then it will open there in a couple of seconds as well. So because you need some communication as well, we provide you with a chat window where you can like type cool commands and ask for generous gifts and stuff. Oh yeah, so here's the cursor syncing. Almost forgot about that. If I select some code, then it will show in the other screen as well in a lighter color. So this is stuff you already know from Google Docs. So you can actually see what you're doing. It's like, hey, check out this part, and you select it, and they can see it. Woo. So now I ask my great leader if he could please fix me the logo and add some stuff there. And we got smileys too. So the other user now has this information on his right side in his own screen. And let me go. So now he thinks, all right, I'm going to change some stuff here. As said, it's probably not the way to do it, but it works. So now I can just change this template and add some text to the logo. And one of the reasons that I ran the Plone instance in the console previously is because what you run there is also synced to the other users. So when I now start my instance here, feed the same thing as I did before, when I move over to the other user after this is started up, he will also see that the instance is running. And you can also see all the stuff that is put on the standard out or standard error. So if there's some some weird error, some of your smarter code compadres can take a look at that and adjust your code based on that information. So when you move over to the other window, you see that it's actually running, and you can pop up the standard out there as well. So when I now go back to my page and refresh, I got a cool logo with like text behind it. And I just did this in a collaborative session with someone else who can be in San Francisco, can be in Australia, doesn't really care. If I need help, if I need to change something in actual code, just call him in and he can edit some code for me or with me. Wow, cool, yay, Jan, oh my God, you're the best. Thank you, guys. So let's quit this thing, and I'm going to show you a couple of the cool things that we offer in Cloud9. That's currently only available for the JavaScript part, but it will come to Python pretty soon, so you can just get used to it already. So the couple of the most, as you see, I'm now offline, so it noticed that as well. So the most amazing features that Cloud9 offers are actually in the JavaScript space. So for example, one of the JavaScript files in Plone is called jQuery highlight search terms thingy. Is it running? Yes. Just go in my find everything. I can't type it right the first time. So this is like one of the JavaScript files in Plone. And to show you some of the auto completion stuff that we offer here. Oh, this is a code outline first. So this is a code outline of this file. You see all the functions and nice inherited and events that you react on, and you can just navigate through this and find stuff really fast. So that's pretty cool. So this will come to Python as well. Wow, yay. One of the things that I really like and that we put a lot of effort in is code completion. So JavaScript is a dynamic language, and the same goes for Python. So it's not like you can like create a nice syntax tree with your complete application in it. So we actually are doing a pretty good job at guessing the types and stuff. So in this case, in the calendar form field, we notice that on the this, on I think it's the same in Python, on this we have a call thing that is an instance of a calendar. And we know it's like a create function and a date and a hide and a refresh and a set range. So that makes you like instantly more productive. And this is probably the best JavaScript inheritance and JavaScript code completion that you've seen. So to show you some of the debug capabilities that we have, I'll write now a simple Node.js application. So we talked about this before. So what we do here is create a simple file called server.js and write a standard Node.js script in it. So Node.js doesn't say, all right, we have a web server. No, it says, I'm going to create a server that listens on HTTP and listens on this port and this IP. So the first thing that we need to do is require the HTTP library. And as you can see here, we have not just code completion, we also have documentation in line for modules that support it. So in this case, Node.js. In this case, we want just the HTTP module. And after that, if we reference HTTP, it knows that it's the same package, and it gives us code completion based on that package. So in this case, we can do create server, because that's what we want to do. We want a server that responds to HTTP actions. And it understands that it requires a function with two variables, request and response. So we can just use autocomplete there. And on response, on every request that comes in for this HTTP server, we will just say, hey, it's okay. We'll put in hello world. That's it. Simplest HTTP server that you can get. So we still need to listen on a certain port. So it knows that as well. And we say, hey, we listen in this case on port 8080. We now run this. You created a super simple HTTP server in Node.js. It even says this. So if you have a Python file, you can just put run and it will run it. That's all. So when I go to c9.dev 8080, it will tell me hello world. That's pretty simple. Wow. You create a demo for that? No, I'm sorry. But the coolest thing that we have here is that you can actually debug this application. And debugging means I can step through it and I can put breakpoints in it and other stuff. So let's put the hello world in a different variable so we can edit it while we're debugging. And reference it here, and it will give autocomplete for our own code as well. As you can see, it knows data, it's a string. And we can do operations on that if we like. So I'll stop running this app, and I will now restart it in debug mode. It load debug symbols. And put a breakpoint there. So when someone accesses my web server, I will break there. So refresh, app breaks. I can hover over response.data to see what the content is at the moment, which is hello world. And I can now change this. Ooh, you can change stuff in hello world from Arnhem or something. Just simple stuff, press enter, it's saved in that context. And when I now continue executing this thing, it will say hello world from Arnhem. So this will come. This will come to Python as well in the next few months. Can't give a timeline to it, but this is basically what you're waiting for. So we do a lot of other stuff, language analysis. We give you refactor opportunities. So let's say you have a variable, but the scope differs and you use it a couple of times. We'll only replace the variable when it's actually that variable that you reference. So it's not like a dumb complete or something. Let me see, that was the end of my demo for now. So I'm going back to my Keynote presentation. So if you got ideas, if you want to add something to Cloud9 because you want to do clone development or something in it, you can fork Cloud9 and actually contribute it yourself. It's open source, you can just run it. So here's a cool thing that I got when I was in the shower this morning. I always think in the shower. Something that developers do, is hey, you have like the tiny MCE editor in Plone. I don't know if it's loved by everyone. I thought so. So in Cloud9, you can access any file system, or any file system. We have a virtual file system layer that you can implement yourself. So we use it for a local file system. We also do it when you do an SSH project or do FTP or something. So wouldn't it be cool to do in a sprint, create a VFS adapter for Plone, where you have like a file system interface to all your content items. They can then open in Cloud9. Then you can edit the HTML of that element, like with multiple persons, and then commit it back and do stuff. So if you want to do something like that, or do something completely different, or grab some parts of Cloud9 and use it in your own project, feel free. We're open source, we're on GitHub, clone it, edit it, and send a pull request. So that's it. Happy coding, guys. And now it's time for some questions. I think there should be a microphone somewhere that.
Hello. You made a reference to Vim, and when you were editing files, I was thinking like, this is Sublime Edit. The interface is very similar to it. Is there? Can you give it? If you don't know Sublime Edit, can you go a comparison between what's different between the Cloud IDE editor and the Sublime editor for editing?
So first of all, the editor that we have is called Ace. I know it's used in the team editor or something somewhere in Plone, as you heard from Rob. And yes, it's pretty similar to, I think you referenced Sublime there, Sublime, yes. It's pretty similar in terms of stuff you can do. We have multiple cursors, they have multiple cursors. And let's say that everyone is looking at each other very good. So if you just want to do local editing and you don't need like the extra integration stuff, so you just want a simple editor on your own machine, you can use Sublime for that. If you want to do more, in this case, like you want to run your stuff as well, if you do want to do project management there, or you want to pull your stuff from GitHub and then edit it and then push it back or deploy it to cloud service like, I don't know, Heroku or Cloud Foundry or basically any cloud service that offers a command line interface, then you want to use Cloud9. I think just like the text editor versus complete IDE arguments here. Does that answer it?
Hello. Is it possible to add some control version system? I'm here.
I'm sorry.
Is it possible to add some control version system, some integration with JIT, for example, some
Yes.
version?
So as you said, it's just a simple Linux server. So if you want to use Git, the only thing you have to do is type Git init. And then Git checkout or something, or Git pull. So we ship with Git and Mercurial for every system. So if you create a new project in Cloud9, we'll ask you, hey, do you want to use Git or do you want to use HG? Or do you want to import something from GitHub? Or do you want to import something from Bitbucket? So yeah, this is all possible. And if you need something else like Subversion, install it. Shall I do a little dance otherwise?
Yeah, dancing's nice.
Hi, I just want to know what messaging technology you use for the chat and the collaborative editing to pass the messages between the users and perhaps the server.
We use a custom library. It's called Concord. It's peer-to-peer with a small server hub. So on Node.js, we have an application running that just pipes stuff through because we can't really do like peer-to-peer over HTTP. And it's completely custom. It's closed source, so unfortunately you can't check it out. But it's also responsible. It basically gives you a message bus that allows you to send, for example, snippets of code. So like when someone edits it, we will send it through the message bus as well. And the same goes for messages. And the cool thing is you can use it for like all other stuff that requires peer-to-peer browser connections, like play like stupid games of Pong, as someone did in Cloud9.
Did you consider using XMPP to do that in the first place, and why did you decide for your own library?
For the chat stuff, I can definitely understand using an existing protocol. But doing code collaboration is actually pretty hard. I think Google has around 30 patents in collaborative editing on their name, because you have to think, because it's not synchronous, it's actually asynchronous. So someone can type on the same moment in the same document. So you already need a lot of custom logic to check out which character is going to appear where. So we needed a message bus for that as well. So it was easier to just plug in the chat messages there as well, because we already needed it for code collaboration.
Hi, I've got a question, but before I just say that, I just want to say, I know you guys didn't necessarily start it, but the Ace editor is really awesome, so thanks for that. Like we do use it in Clone, and it's really good, so I think that's actually a great piece of open source code. The question I had, you kind of mentioned it, but I just wanted to check. So there's a free version of this, and if we could get Clone to run on the free VM, which we might be able to do, does that mean that we could have a sort of an unlimited number of people doing little collaborative projects? So let's say we have a sprint, we've got some people on site, some people, in another country. At what point do you need to start paying? So could they be working on things collaboratively, checking into GitHub, running a shared instance on the free accounts?
So yes. So what we need to do actually to get this running is have the Clone unified installer or something, have it compiled, then put that all in the Git repository. So we'll just say, hey, all right, clone this one, then you can edit Clone. And then basically everyone can use the project and they can clone it themselves in Cloud9, just on a free plan, no cost attached or something. And then they use it the normal way, by just doing Git pulls and Git pushes. And if you need assistance, you give them your personal URL, and then they can edit, they can help you with stuff like that.
So at which point do you need to start paying? What's the feature that?
I'm sorry.
When there's a paid for plan, right? $12
Yes.
a month or something. But what's the feature that you get for that?
At the moment, on the free plan, so we've got two plans. Free, it allows you, the virtual machine that we give you has limited RAM. I think it's like 256 MBs of memory or something, which is pretty much enough for most of the stuff that you do. And on the premium plan, we give you 512 MBs. And on the free plan, you're limited to one private project. So you can have unlimited public projects. If you do like open source stuff, feel free to use it. If you do private stuff, then you only have one project on the free plan. And if you want more, then you can upgrade to our premium subscription.
Okay, thank you.
Last question.
Thank you for your perfect tool. It looks very good, but I'm a skeptical guy. I'm coming from Finland, so
I'll be skeptical as well. Yeah.
I think you skipped your the most biggest part in your ID, and it's the browser. Like for example, the browser doesn't handle keyboard that well and stuff like this. So do you have this kind of issues with your ID, and should I just stick with my desktop for now?
So yes, there are a couple of issues with the keyboard in the browser. Most of the things you can override by now, and you can either do that by just be smart, so you can, I don't know, override like all the Command C and Command V and all the basic stuff. And otherwise with a plugin, because Chrome allows you to override more keys then, if someone installs your plugin first. The things that we don't do is Command W, Command T, and Command N. So if you do that in Cloud9, you have to use Alt. So that's basically the only modifier that we have. And other than that, we pretty much offer all the keys. And if you need more, just extend it yourself and send us a pull request. That's it, I think.
That was it. Thank you very much.
This will be finished before lunch.
I'll check that.
Thanks.
Thank you. Hey, thanks a lot.